Okay, let's see. We've got 2 math workshop questions. We're actually only going to do one of them today. They're both a little out of our league, meaning that they require a little more of our notes than what we've gotten to at this point. But that's okay. We can still fake it with 17 and make it happen. But 18 we're going to save till tomorrow, still in it. Okay, let's see. First things first, ignoring the 0, is there a GCF I can pull out? 3 what? X squared. Thank you, Ellie. You can have a point. Okay, if we pull out a 3x squared, we're left with an x to the 4th minus 13x squared plus what? 2 and 5 is the point. Okay, so we pulled out a 3x squared, and now we've got x to the 4th minus 13x squared plus 36 equals 0, which seems great and all, but we're still not done. No. So the difference between this and the ones we've been doing is that first word, solve. Another reason we should have recognized this one was different is because of the equal sign and the 0. So we actually need a set answer for this. Whereas in the past we factored and called it a day. Today we actually need to have like x equals 4, x equals 0. Okay, so let's pretend this problem was a little different. What if we changed it? What if instead of x to the 4th, it was x squared? What instead of x to the 2nd, it was 13x plus 36? Can we factor x squared minus 13x plus 36? What? 2 gets the point. Negative 9 and negative 4. Negative 9 plus negative 4 is negative 13. Negative 9 times negative 4 is positive 36. So those would be the factors. But sadly, those were not our exponents. Our exponents were a 4 and a 2. But it's still going to all work out. So we've still got, let me move over a little. We've still got the 3x squared. We've still got the equal 0. We're going to use the minus 9. We're going to use the minus 9. We're going to use the minus 4. But instead of x, we're going to do x squared. Okay, now if we were to, if you're questioning your sanity at this point, we were to FOIL it out. X to the 4th for the first. Outer, negative 4x squared. Inner, negative 9x squared. So that does make the negative 13x squared. And then last, negative 9 times negative 4 is positive 36. So when we FOIL these two terms back out, we do end up with that top set of parentheses. Okay, but we're still not done factoring. We've got the 3x squared. He's good to go. But that x squared minus 9, I can break up. What can I break it up into? Okay, I heard it first from Jax. We'll give him the point. What about the other? I'll give it to all of you this time. 2, 4, and 5. Okay, so we've got this really long thing. We broke up the x squared minus 9 into these two. We broke up the x squared minus 4 into these two. We still have that 3x squared on the outside. And sadly, we still have that equals 0 part. So we've got a little left to do. We need to set each of these terms equal to 0. So we have to set 3x squared equals 0, x plus 3 equal to 0, x minus 3, x plus 2, or x minus 2. We've got to set them all equal to 0 and solve. So we're actually going to end up having 1, 2, 3, 4, 5 answers. And to be honest with you, depending on the exponent, that tells you how many answers you could potentially have. So since our exponent was 6, we potentially could have had 6 answers. So if our exponent was 9, we could potentially have 9 answers. So we've lived in this sad world where our exponent's always been 2 and we've only had 2 answers. But there can be more. Okay, so if I set 3x squared equal to 0, that's the first one. And I set x minus 3 equal to, x plus 3 equal to 0, x minus 3 equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. I set them all equal to 0. I took each of them all by themselves, put them equal to 0. The 3's and the 2's are easy. What do I get with the first 3? X equals what? Yeah, so I get negative 3 here and positive 3 here. And so if we wanted to combine that, we could say x equals plus or minus 3. He's correct. And with the 2's we get, yes, so, and 2 and 4 can have the point. So x equals negative 2 here, x equals positive 2 here. So since we have negative and positive 2, we can write it as plus or minus 2. So we've got 1, 2, 3, 4 answers. We have one answer left with that 3x squared. What is our final answer? 2 gets the point. So if we divide by 3, we would have x squared equals 0. To get rid of that squared, we take the square root of both sides. The square root of 0 is still just 0, so our answer is 0. So those are our 5 answers. Now, if you recognize at this point up here, fell on the screen. Let me zoom out. If Daniel recognized in this step, I'm going to put an arrow by it. Second step down. If he realized, hey, x squared minus 9 is going to end up having the answers of plus or minus 3, and x squared minus 4 is going to end up having the answers plus or minus 2, he doesn't necessarily have to do the next step that we did. If you understand how perfect squares work and that they're always going to have the positive or negative answer, you'll be fine. You don't have to necessarily do all of this work. So yeah, it was a little out of our pay grade, but it still involved the same concepts we understand. It still involved pulling out a GCF, factoring, like normal factoring with a leading coefficient of 1. It still involved perfect squares, factoring with those. The only thing that was a little out of our league is that we had to set each of the factors equal to 0 to solve. We hadn't quite learned that yet, but we can fake it. We will save number 18 for tomorrow because it is also a little out of our league. In your notes, we did 1, 2, and 3 yesterday. Let's look at number 4. Okay, we have a couple more examples today. Then I'm going to let you work on page 7 in the notes, which is like 6 problems you need to do on your own. And then there's also a checkpoint, and we'll talk about that in a second. Okay, so the things we need. We've decided we're being lazy. We're not actually going to draw our own graph. We're not actually going to make a table of values. All we're going to do is list the important parts of a parabola. So we need to know its y-intercept. We need to know its axis of symmetry. We need to know its vertex. Does it have a min or a max, and where does that happen? And of course, we need to know domain and range. Two of these I can fill in without even graphing it on my calculator. The intercept is at negative 12, so you can put negative 12 or you can put the ordered pair 0 and negative 12. Either way is right. 2 points for 5 because I knew both of those. No, 4, sorry. Not 5, no offense, Gilberto. So we can automatically fill in the intercept. We can automatically fill in the domain. I told you that domain is going to work unless it's a real-world problem where they restrict the domain. Any other ordinary problem, that's the answer. So all we're really graphing to figure out is where that vertex is, because if we know the vertex, we can fill in the rest. So you press on, you press y equals, you type in negative x squared minus 12, you press graph, and then, I don't know about you, but nothing ever showed up on my screen. So if that's the case with you, that just means our parabola is off this view, so we need to zoom, and then how did we say it would be easiest to get to our parabola? Fit is going to fit your parabola. Now, I'm not saying it's pretty, but at least now I have a graph. Okay, but we need to know, so is it a max or a min? It's a max, and that's actually something we automatically should know. So I don't know if we went over this yesterday, but there's a negative in front. It's going to end up being like a mountain. It's going to face down. If it's a positive number in front of the x squared, it's going to end up being a min. So because it was a negative, I already knew it was a max. Okay, but we would like to know exactly where that max is occurring. So how do we figure that out? What do we ask the calculator? How do I get to where I can determine where that max is? A trace is great, but not really. Trace is really not that great because trace is just kind of wandering around the parabola. So I think it's 0, negative 12, but I'm really not sure. I like to go to the table. So since it is a max, we're looking for the highest number on that second column? What is the highest number you see? And you can scroll either way.
48.
Those are really big negatives, so you want the smallest negative.
Oh, yeah, that was a break.
Yeah, so we'd want negative 12. So it's 0, negative 12 is going to end up being what? Yes, so 0, negative 12 is our vertex, so 2 and 5 can have the point. Our vertex is at 0, negative 12. It means we have a max at negative 12, because if we look at our graph, again, eventually it stops, so we have a max at negative 12. And what's really strange about this one is our axis of symmetry, because our axis of symmetry is, okay, so the x-coordinate tells you the axis of symmetry. The y-coordinate tells you the min or max. So our axis of symmetry is at 0. So what does that mean? Look at your picture. What does that mean about that axis of symmetry? Where would we cut it? You would cut it down the y-axis. How cool is that? Okay, so we still have to do range. So my range is from what to what? Yes, Paige gets the point. So it's negative infinity because I can touch it down here, but eventually I can't touch it anymore. So it's negative infinity to negative 12. That's where I stop touching it. Okay, are there any questions about this? We talked about something yesterday, though. What's another button that could have helped us figure out that min or max? Okay, and why we need second calculate is because the table lets us down. Why does, and you can have a point for that. Why does the table let us down? It doesn't have the decimals and fractions. And so I'm going to give you a checkpoint today, but number 2 of the checkpoint, the table is not going to save you because it ends up being a decimal or a fraction. Okay, but let's go back. If Nick, I've had to call him Nick. Why? I've had him for 2 years. Surely I know his name. If Nick really likes formulas, which he does, he can still just calculate that axis of symmetry by hand. He's just got to remember negative b over 2a. He can always plug that in and get out that axis of symmetry and then end up calculating all this junk by hand. No one is saying Nick can't do this by hand. In fact, if he did it by hand and he checked it with the calculator, then he'd be awesome. I'm just saying a majority of us are better at, because you're good at your phones, are better at button pressing than we are necessarily at remembering some other formula in life. Okay, we're not going to do number 5. Let's skip ahead. Let's go to a fun one. Hold on, let me decide which one's a fun one. 2 does look fun, but almost like too much fun.
Number 3.
I'm looking at number 1 to see how much fun it is. Zoom. Yep, number 1. Number 1 is fun. Okay, let's do number 1. It doesn't look like fun, but it is a ton of fun. We actually are not going to worry about x-intercepts yet, so if you want to change that word to y-intercept, I totally understand. We'll worry about x-intercepts another day. Okay, so you need to graph number 1 on your calculator, and I need some of these answers. And of course, this list is annoying me because it's left off some of the things. I'm a creature of habit. So it's got vertex, it's got max and min, but what is it missing? What is it missing? Okay, Nick had it out first. We'll give it to him. So I'm going to add that to my list. I like to make the same list every single time, so I get annoyed when people leave things off. I always do vertex, axis of symmetry, max, min, the y-intercept, domain, and range. I always do the same 6. Okay, so we've graphed it. And we know some things. What are some of the things we know? The y-intercept is 4. The what is? The domain is negative infinity to infinity. It is a max. How many points are out, Jax? That's what I thought. You can have one more, and 3 you can have another. Okay, so we've got a lot of the basics. Now we just need vertex, axis of symmetry, and range. So, since it's a max, I thought, hey, I'll press second table. I'm just looking for the largest number I see in my table. What's the largest number you see in your table?
4.
I see one bigger than 4. Did I type it in wrong? Are you looking? You don't even have it up. You don't know.
Bigger than 4.
So I did negative x squared minus 3x plus 4. Negative x squared minus 3x plus 4. I press second table. And I don't know what y'all see, but I see a 6. Did you scroll? You know it scrolls. It scrolls up. It scrolls down.
What determines that?
It scrolls up. It scrolls down. The biggest number we see over here. Big says we have kind of a dilemma now. Why do we have a dilemma? There are 2 6s. So is the vertex negative 2 6 or is the vertex negative 1 6? You know that we finally reached the point where this table has let us down, hasn't it? It wasn't supposed to have 2 things. We only need the one thing. Guessing one of them is not going to work. So, darn you table. Table's not helpful. So we go back to the graph. Trace button's not a bad idea, but I trace, and I'm like, it looks like maybe negative 1.56, because it says like negative 1.489, 6.2, and that's great, but I don't like just randomly guessing. Maybe you do, I don't. How do I know I have my cursor exactly at the top? I don't. So trace seems great, but not really. Trace is not going to save the day. We need to second calculate. We're not sure where that max is happening, but we need to know. So we're going to press max. Now, again, the only reason people don't like second calculate is because it requires a little more work than just scrolling up and down on a table. You have to, it says left bound, so since we know this max is here, when it says left bound, we've got to pick a spot a little to the left of that mark. It doesn't matter if you go really far to the left, just a little bit to the left, literally doesn't matter. Now, you would say, calculator, I see that graph. It only has one max. Why are you making me set a left and a right bound? Because your calculator can graph more than just this function. So what if we had some sort of looking like an M and it had another max? Then what would we do? So our calculator doesn't know exactly what kind of function we graphed. The calculator can't help that we've graphed an easy function with only one max. The calculator is needing us to restrict exactly where you're looking for this max. So we pick the spot a little to the left. We'll pick a spot a little to the right. Where'd my monster cursor go? See, he's blinking now. You can blink him. He's blinking right there. You can put him further down. There's fine. Doesn't matter. I press enter. So you see those 2 arrows at the top? That's my calculator letting me know, hey, when we guess, when we tell you the answer, that max is between those 2 arrows. You're telling us the max is between those 2 arrows. So if your calculator fails, no offense, up to this point it's been a manual error, you didn't set those arrows nicely. You don't actually have the top of that hill in between the 2 arrows. Okay, but then here's the part where if I could redo calculators, I would fix it. I would fix this last thing. So it's not enough you set it a little to the left for the left bound, a little to the right for the right bound. Now they want you to make a guess. So I know Tylen. She is a perfectionist. She's going to sit here and scroll and try to get exactly dead on. And that's good for her. She doesn't have to do any of that. She can be as off as she wants to be. Once you guess wherever you guess, it's going to tell you the answer. So our max is at negative 1.5, 6.25. So going back to our list, we just figured out that vertex is negative 1.5, 6.25. Where's my list? Why is it not on the screen? We know it's a max. It's a max at 6.25. We know that axis of symmetry is x equals negative 1.5. And then the last but not least, we know the range is from negative infinity until 6.25. Because I could touch it forever until at some point I stopped being able to touch it. And I stopped being able to touch it after we hit the top of the mountain, and we just decided the top of that mountain was 6.25. Okay, is there anyone heartbroken over this? Okay, again, you don't have to be this person. you can calculate it by hand. The axis of symmetry is negative b over 2a. So for this specific problem, negative b would be negative 3. 2a, a is negative 1. I already knew it was going to be at 3 over negative 3 over 2, which is the same thing as negative 1.5. I already knew, because I can calculate it by hand, where that axis of symmetry and where that x-coordinate of the vertex were going to happen. I could take that number, plug it back in my function, figure out that y value, which would then tell me the max value and the range value. I can do all of this by hand. I don't have to use my calculator for any of this, but I can. Okay, are there any questions about this? Then we'll save number 2 for tomorrow because I just don't even feel like talking about fractions today. Let's do number 3 and then I'll let you get to work on your life. Number 3 is 2x squared minus 6x minus 9. That looks really familiar to me. Please tell me that's not the exact one from this. Oh no, okay, cool. 2x squared minus 6x minus 9. Now I already knew negative b over 2a. It's a pretty axis of symmetry, so I don't know why it's on this section. It might be an easy one. Well, it didn't fit in Zoom Standard, so I'm going to have to Zoom fit it. Got to add axis of symmetry to my list. Okay, help me fill in the things we already know, please. Negative 9? Oh, I'm looking at the wrong thing. He's right. It's a negative 9. You win. It has a minimum. That's a y-intercept. Something about axis of symmetry. But I'm telling you, I can...
Nurse Laurie, please go to room 139. Nurse Laurie, you're needed in room 139. Thank you.
Interesting. Y'all know that's near us, right? Okay, cool. I get real nosy real fast. Moving on. We've got this. We got to figure out the rest. We got to figure out that vertex, which is going to help because we know it's a min. If I look at my second table, I'm looking for the smallest number possible, and oh no, I have the same issue we had before. I see negative 13 twice. So I can't just say, well, the difference of 1 and 2 is 1.5, so maybe it's 1.5 negative 13. That's not a bad thought. It probably is that, but I'd like to know I'm right. So I'm going to second calculate and figure it out. When you second calculate and figure it out, tell me your answer. So I'm going to round that to 1.5. And negative 13.5? That's what she said. I'm going to actually do it myself and make sure she's not crazy. She's normally not, but sometimes people get crazy. Left bound, I pick a little to the left. Right bound, I pick a little to the right. Literally doesn't matter where you guessed. And that's not what I got. Did I do this wrong? 2x squared minus 6x minus 9. Second table. Second calculate. I want to know the min. A little to the left. A little to the right. Guess. Yeah, I agree with. Well, no, I don't know what I agree with. Question my whole life. Second calculate. I want to know the min. Okay, she wins. let's talk about why it took Miss Compton a hot minute, because I'm betting you had the same issue. So I, like you, get a little antsy. I like to know answers pretty fast. So I did second calculate. I told it I wanted them in. And then I got really lazy because I have a terrible zoom right now. So I really don't know where the bottom is. So I'm just literally guessing. So if that's you and your screen looks ugly like mine, you probably need to go pretty far to the left for the left bound. So it's probably best that you actually see your monster cursor lighting up before you press enter. Because if you're just assuming he's in the great below and to the left, you don't know that. So you want to actually see him lighting up and feel better about yourself and press enter. And then when you scroll to the right, yes, it does take a few minutes because apparently this bad boy went pretty far down. But again, you want to wait till you see that monster cursor lighting up. Come on, monster cursor, where are you? You want to actually know that he's still alive before you press enter. And then it doesn't matter where you guess. And I got 1.5, negative 13.5. Now, if yours is a little different rounding than mine, your calculator sets around differently than mine. No big deal. I tend to round to like 1. So if it was 1.49, I would have rounded to 1.5.
But mine was really off. And I did the same points as you, like with the left bound.
Did you type in your equation right?
2x squared minus 6 is 9.
Okay, did you, for real, when you did the bounds, did you make sure they were really far to the left and really far to the right?
I did the same thing as you.
Okay, then I will look at yours in just a hot second. Okay, let's finish what we were up to. So we know the vertex, which means we can fill in all the rest of the stuff. The min happens where? Table 5 gets points, negative 13.5. Where's that axis of symmetry? 3 and 5 get the point. And then what is my range? That's wrong. 1.5 to infinity. So if it's a min, oh, it's not 1.5 either, man. God bless you, Jax. Somebody helping me out today. We could touch it forever on up here in positive infinity, but there was some point down there at the bottom where we stopped touching, and I bet that's where that min happened, and that min happened at negative 13.5. Again, it probably would have all been better if I had zoomed differently and I could have seen my picture better. Yeah, I didn't, because I, like you, am lazy. Are there any questions about this? I'm going to hand you a checkpoint in just a second. It's not due at the end of class today. It's okay if it bleeds over into tomorrow. No one's mad. Flip over. It's page 7. It's like 2 pages away on the back. There are literally the same problems on the top and on the bottom. So cross off the bottom ones. Don't know why I made the same copy twice. Whoops. You don't have to do the same problems twice. I know that Karen is a direction follower, but I'm telling her to ignore some of the directions. I don't need a table of values. I don't need an actual graph because I'm assuming you graphed it on your calculator. All I need is our normal list of 6. Did you do the y-intercept, the axis of symmetry, the vertex, min, max, domain, range? If you did those 6, that's good. But there are 6 problems, and you have to do 6 parts, so you understand why this is going to be worth 36 points, because 6 times 6 is 36. Okay. Go ahead and get started. It is not due today either, but it will be due at the end of class tomorrow. Do all the things. Okay, Angel, let's look at that.